The Doc is In is sponsored by Amada Senior Care.
Fox 56 News Chief Medical Contributor Dr. Ryan Stanton with us in studio.
And this morning he's focusing on something I'd say is pretty important, the air.
It is pretty important. It's a part of our everyday lives. So here's the crowd participation part of today's talk.
Oh, we're getting tested?
Yes, quiz. I didn't tell you that because we were busy trying to figure out how to make my microphone work. So, all right, so what is the primary gas in our atmosphere?
Nitrogen.
What?
Is it? I don't know. Is that right?
Our primary gas in our atmosphere.
I mean, you have guesses right here.
Probably carbon monoxide. No, that wouldn't be good either.
No, that would be bad.
That would be really
it
bad.
is actually, you said nitrogen, right?
Yeah.
Great answer. Great answer.
You made it sound like it was crazy that I suggested that.
That's what I thought too.
I wanted you to feel a little bit of fear for a second there because you were pretty confident earlier before we came into the break about nitrogen, so I knew you were going to get the right answer. That does actually make up most of it. Let's get right to it. Nitrogen actually does make up about 78% of our atmosphere, oxygen about 21%, and everything else makes up the remaining 1%. Yeah, that's our pie graph right there. So a lot of nitrogen out there. All that balance is very important, but there are two things that play into the air that we breathe. When we go to altitude, atop of a mountain or potentially an airplane, we may not be able to breathe as well. That has to do with two laws. One is Boyle's law. That has to do with the column of air from our pressure of our gravity pushing down onto the particles and pushing them closer together. The higher the pressure, the closer those molecules are together. The closer you are to the core of the Earth, the closer they are together, and just the opposite when you're at altitude. The other one that plays in is called Charles' law. Charles' law has to do with the amount of temperature or heat. Heat actually makes those particles move away from each other. That makes that air move apart, and that's why we have hot air going up higher, the reason behind hot air balloons. Now, this is important in terms of breathing, because our lungs don't change how much surface area there is with regard to altitude. So when we go to altitude, higher altitude, those air particles are farther apart, making it more difficult to breathe, potentially because we don't have as many air particles coming in contact with that lung tissue. So that means if you go to altitude, especially with chronic lung disease, you may have more difficulty breathing. Coming up in our second segment, which is 1 hour away, we're going to talk about how technology makes it able for us to breathe at altitudes because of the potential use of the pressures that we see out there to get those molecules closer together. So interesting physics, not a traditional medical discussion, but I didn't want to hurt Paul's feelings today about choices and life decisions such as diet sodas. But we are going to talk about how we're going to make sure that you can breathe when you're traveling around the globe.
Quick question, we're short on time here, but I have no trouble sleeping on a plane. Is that because oxygen's not going to my brain as much as it would be down on the ground?
That could be, but it's not. It's typically the white noise. It's the noise associated with the engines that will often distract you and allow you to sleep a little bit better.
Okay. Fascinating. All right, we'll see you in 1 hour, Doc. We'll be right back.
You're watching Fox 56 News. Our home, your news.